Hello, this is Mrs. Rapaski, and this video is about electron diagrams, the arrangement of electrons in atoms. This is for Chemistry 1 class, Chapter 5, Quantum Mechanics. Electron arrangements tell us how the electrons are arranged within an atom. When we look at an atom, or inside an atom, as we have in this picture, we can see that there are different areas for the electrons to be arranged. Some of the areas where the electrons are spheres, just as Niels Bohr described, and some of the spheres have to be broken down into parts, and these are called orbitals, an area that Bohr didn't know about at first, but quantum mechanics helps us describe. Each of these parts is a place for two electrons to go. All of the orbitals are arranged in order of increasing energy. As we have here, increasing energy, and they start on the lowest level and work their way up to the highest energy levels. So here we have, in this diagram, we start with the first energy level, go to the second energy level, and we also have electrons on the third and fourth energy level. When we look at the periodic table, we see that the periodic table can be divided into those sections that name the orbitals. So when you do your electron diagrams, you want to find your element on the periodic table, and then as you read the periodic table, you will read as we read in English, going from the left across to the right, and you will read one row at a time. Every time you get to a row, like on the second row, you will name each part, and each part will have a number and a letter, like the 2S or the 2P. So every time you're in a different section, you have to identify the energy level and the sublevel. So let's do an example for the element fluorine. So we find our element on the periodic table. We see that fluorine is in the second energy level. So we need to include two energy levels of electrons for the atom. Fluorine's symbol is F. So to start our electron diagram, we start with the symbol for fluorine and place a colon. This just makes everything nice. When we read, we start in the upper left-hand corner. We start in the first section, and we see that in the upper corner it says 1s. The 1 stands for the first energy level, the s stands for that sublevel. An s sublevel will always have a single orbital, which we represent with a single line. The boxes 1 and 2 for hydrogen and helium each represent one electron. The first electron will have an up spin or a positive spin, so we write an up arrow. And the second electron will have a negative spin, and we will write it as a down arrow. Electrons are charged objects that can spin, and the spin creates a field. So having two opposite spins makes the fields cancel each other out, and then the electrons won't repel. After we have our two electrons, we've gone through the two boxes on the first energy level, so we're ready to look at the second energy level. As we see in the first column, it says that we are in the 2s section. So we identify where we are by writing the 2s. An S section will always have a single line after it because an S always has a single orbital. It does not matter the number in front of the letter S. In the 2s section, we have two boxes, 1 and 2. So we put two arrows just as we did before, an up and a down. When we're finished with that section, we jump the void to the 2p section. Okay? And this is where fluorine is. Okay? So we notice that we'll be doing 5 electrons. And back to our diagram, we have to identify the section where we are, which is 2p. The 2p section always has 3 orbitals, so we will draw 3 lines. And it will take us 5 boxes to get over to fluorine. So we put in our electrons. Now as we're filling in our electrons, we have 3 different sections, so each of them needs to be treated equally. This is Hund's rule, or as I like to call it, the cookie rule. Everybody gets 1 before anybody gets 2. And then if you have extras after everybody gets 1, then you fill them in until you run out. Since fluorine is the 5th element over, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We have 5 electrons. Since we're at fluorine, we're finished. If we go back and we count all the electrons that we've drawn, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that number 9 matches the atomic number of fluorine. So every time you finish the electron diagram for an atom, your number of electrons should match the atomic number. Okay. There is a shorter way to do an electron diagram, and that would be to write it out, and instead of writing each electron as an arrow, we just count how many electrons we would put in that section. So I'm going to clear the marks that I made before. Okay. And if you'd like, you can follow along again. Okay. We're still going to do fluorine, so we will put the symbol for fluorine and put a colon because that makes it nice. We're going to start reading on the upper left side of the periodic table, and we see that it says 1s. Now when we were doing the orbital diagram, we looked and we had 2 electrons. Okay. Instead of drawing the 2 electrons, we were going to put a superscript 2 because we would have drawn in 2 arrows because we have 2 boxes. 1 box, 2 boxes. Now the first row is finished, so we go to the second row. We identify where we are, which is the 2s section. We count how many boxes are there. 1, 2. We would have put in 2 arrows in an orbital diagram, but now we just write a superscript and we say 2s2. We continue across the second row of the periodic table. We see that we are now in the 2p section, so we identify that by saying 2p. And then we count how many boxes over to fluorine. 1, 2, 3, 4, 5. So that becomes our superscript. And then to check our work, if we add 5 plus 2 plus 2, 5 plus 2 plus 2, that equals 9. And 9 is fluorine's atomic number. In your notes, you have the example for potassium, so please do the 1s up down and the 1s2 for potassium, and then check in your notes to see how well you did. If you have questions, please ask for assistance, ask your teacher, or ask a classmate. Thank you for watching.